this. Yeah, so one thing I do quickly want to do is give a little bit more guidance on some of the conceptual design code. If it's still open, which it is almost certainly not. Give me a second, sorry. All right. So the way one thing I just kind of wanted to be a little bit more clear about was the fact that you should think about what I have in this sample script. So all of these outputs, the like lap time and stuff like that, in the context of those scoring equations that we went over and that are in the rules. So for mission 2, for example, the time it takes to fly 3 laps is one part of the scoring equation, and the takeoff distance is another part of the scoring equation. So if you can combine those 2 parameters, the lap time and the takeoff distance, you can get like a good chunk of the way towards just a score just based on that. And so what I kind of want you guys to think about is like how you could combine those functions to potentially get an even more detailed score, including like the number of payloads, basically, because that's the only other component, right? It's the lap time, the takeoff distance, and the number of payloads. So if you can figure out a way to like iterate through the number of payloads, for example, for each wing loading and power loading, you can probably get a pretty good first pass at a score function, if that makes any sense. Yeah, any questions on that? And anything, I don't know how much you guys have looked at since Monday, but if anything else has come up, you guys have questions on that either?
Okay, do we want to kind of start trying to figure out how to optimize the equations and stuff? Andrew?
Yeah, I was just going to do that. I'm going to write down the equation, see if I can like input all the values. So we have like, we don't just have like M2 or like M1 like in the equation, we have like the actual parts of those. Then I can probably get a little bit like of a general equation that we can start to work on. That'll take me a couple seconds.
I was thinking it'd be a good idea to kind of take all the equations and plot them in MATLAB somehow, just so we see like what the most important parameters are.
Yeah, we can do that too.
That's a good thing. We do that every year, so you should do that.
Cool.
Okay, cool.
Yeah. In the meantime, I'm gonna open up a breakout room, and I will assign you to it, Thomas, and I can just give you a brief overview, and then.
You have the power to do that, Laird?
I do. Okay.
What's the WRS for our score? Is that, it says a written report score.
Yeah, so that's not something you can control as far as the design, but I included it because towards the end you're going to be working on a report, and that's how the DBF score scales as well. Is they multiply the score, like your flight score by your report score. So.
Okay, should we just set like a value for that right now?
I would personally, I just wouldn't include it at the moment.
Okay.
I would just focus on optimizing the mission score, and then whatever you get is going to scale. So yeah.
Just the mission score or the entire score?
Yeah, sorry, like all of the things that you can actually like directly control based on the plane. Yeah. So
okay. Thank you.
Basically everything except report.
Right. Cool.
Cool. All right.
Optimizing for the report score would only matter if you somehow had to like decide like how much of your time are you devoting to making a good plane and much of your time are you devoting to writing about it.
Exactly.
But
Alright.
That's the important kind of optimization.
Basically, just a
Hey.
Hey.
Yeah, so basically what I guess I don't know what do you know about the club coming in? Like where did you find us?
I went to an informational meeting my freshman year.
Okay.
And went to like maybe one or two of the first couple meetings, and then kind of fell behind in coursework and so never went again. And then COVID kind of happened. But from what I remember, competition for designing kind of like a RC aircraft that is scored a certain way, and then the club kind of works on like a project for the year to compete in that, was what I remember.
Yeah, pretty much that's pretty much it. What year are you, by the way?
I'm second year.
Okay, cool. And Arrow or
Arrow, yep.
okay, cool. Yeah, well, so I'm the lead engineer for the club, and you saw Johnny and Becca in there. Johnny is president and Becca is vice president this year.
Okay.
And right now we're doing like a mock competition. So we're basically having all the freshmen and sophomores design a DBF style plane from kind of the ground up. So, what's up, Jack?
Hey, I'm just trying to make some code in MATLAB to plot some score stuff. So I'm just, I don't know, I'm making some variables. And I'm
Okay.
gonna try to figure out how to work them back to the sample script somehow.
Okay.
You know,
what's up?
What's up?
hey,
We saw Jack over here, so we're like, what's going on?
That's also what I was wondering.
oh, I thought this was a breakout room for us. I don't know.
No, sorry, my bad. I was just trying to get Thomas up to speed here. On like what's going on.
Okay, we'll go back to the main.
Yeah.
Have fun.
I'll be back in the main soon. See ya.
Okay.
That was funny. I was like, wait. What? Sorry. Yeah. So as Jack was mentioning, right now they're working on doing some conceptual code. So the idea, more or less, is to get a takeoff weight, wing area, and power for the aircraft.
Okay.
Just kind of like basic parameters that they can then take and like do some more detailed design on. And so if you look in the Slack, in the mock comp channel, pinned, there's a rules PDF.
Rules PDF. Let's see.
It's like 2021 DBF mock comp rules.
Yep, see it.
And so that kind of outlines the DBF style project that we're having them work on right now. So yeah, there. If you look at, I guess, page 2 and 3, there's some scoring equations, and so the current task at hand is to try to make some code that will attempt to optimize those like variables, those like that like wing area, power, and takeoff weight, to try to maximize the score. Yeah. If you look also in that channel, there should be a pinned zip file.
The MATLAB code one?
The MATLAB code one. Yeah.
Okay, yeah, I already have that one downloaded.
Okay, sweet. So if you run the sample script, what that'll show you is what we have kind of the capability to do so far.
Okay.
And then I basically just put the performance code that we have, or that we've had previously as well, into this script. So it runs through a bunch of, sorry, one second. This WOS variable is the wing loading, which is the takeoff weight divided by the wing area. And then this power to weight is power to weight ratio. You can see if you look at some of the slides that have been posted. Actually, they might not have been posted. Yeah, I should post those. My bad.
all good.
But and the recording from, I think, yeah, the first conceptual recording. We talk about why we kind of use those variables at first, as opposed to just like wing area, takeoff weight, and power separately. It just turns out the equations play nicer when you divide everything by the weight.
Okay.
Yeah. So what we can do with those parameters is we can calculate the top speed and like the lap time and stuff.
Oh, I see.
At each of those points. And then we can calculate the takeoff distance as well. And then we can calculate some other stuff. If we also give it a takeoff weight, then we can calculate like empty weight and stuff like that as well. And then this is just a constraint style diagram with like some sample numbers in it.
Gotcha.
I take it you're probably in Aero 300 right now, right?
Yep, that's
Okay.
Aero 300 and 299.
Yeah. So you guys have already, I think, done like contour plots or whatever.
Yep, yeah.
So okay, cool. Yeah. So then the other thing to think about is that all of these calcs assumed these variables as constant.
Oh, I see.
Stuff like aspect ratio, you might not want it to be constant. You might want to vary that in a function. Personally, I think almost everything else you would want to assume is constant for now. Aspect ratio might be the exception, or you might want to assume it's constant. I don't know. That's up to you guys. But just like these are all kind of assumptions in the lap calc code, this lap calc parabolic wind, and the DBF takeoff code all assume these things. And then this weight estimate code also assumes these things.
Gotcha. Okay.
So yeah, that's where we're at right now. So far we've had, I guess this is meeting 5 of mock comp. So the first meeting was just intro and that type of thing. Second meeting was like early performance equations. So the stuff that's inside this lap calc code.
Okay, the actual functions.
Yeah, like we talked about those equations in more detail in conceptual meeting 1.
Okay.
Conceptual meeting 2 was like kind of more general about aircraft configuration. So like, monoplane, biplane, what kind of wings you want, that type of thing. And then Monday was mostly another work day as well. So yeah, that's where we're at.
Cool. So I'm guessing it'd probably be pretty worthwhile to go through and watch those first couple YouTube videos to get up to speed on that kind of stuff.
If you want to, you can probably do it at like 2 times speed as well, because they are kind of long. But yeah, if you got time to do that, I would say it's probably worth it. For today, though, I think you can probably start contributing just in the conversation out in the main room. So yeah, any questions on that stuff?
No, so from what I gather today, what they're working on is just based off those scoring equations that were in that PDF. You're just trying to, based on the constants you set, and design, like basically make a function that scores the aircraft based on like the different parameters you set.
Pretty much, yeah.
Cool.
Sweet.
All right, I think that's
Go ahead.
I think everything makes sense. Yeah.
Cool. Yeah, I think there is also it might be pinned. Yeah, there's a Google Docs pinned that that was started to just kind of keep track of some stuff. I actually haven't really looked at it because
is it the off seasons plan one?
Off-season plan would be good to look at for the schedule, but it's the mock competition Google Doc that I want to say one of the other freshmen and sophomores made, and they're just using that. They've been using that to keep track of ideas.
Oh, I see it. Yep.
So, yeah.
Got it. Sweet.
All right. I'm gonna close the room then.
Sweet. Sounds good. Thanks for your help.
Yeah, for sure.
Higher just raises our score a lot.
What is QFL?
Kickoff field length, maybe?
Yeah, that's a
Yep.
takeoff. That's for our
Mm,
mission 2. Or mission 2. And we have to take off and then do the 3 laps in the shortest amount of time.
okay.
We do. I'm not really going to explain the crates and containers, so that's a given. Kind of.
Are you guys just coding the equations based off of the PDF file?
Yeah, that's what I.
I'm
I
typing in our. Do you have the Google Docs?
Yeah, I have it pulled up.
Cool. Also, why when we all log in, it's like anonymous giraffe and like anonymous wolf? Is like a setting.
They're not shared directly. You're not added directly to the document. You're just given the link. I think if you're added directly to the document, it would be your name attached with it.
Got it. Okay.
It makes it easier to impersonate the club leadership, though.
I think Peter created the document, so he would be the one that would be able to fix that.
Okay, so So I create a list of missing variables that we have to figure out before we can run this equation, basically. So in order to run this, we have to start making some decisions or assumptions for now. I kind of feel like it makes most sense, or intuitively to me, it seems like it makes more sense if we have one Jenga block per shipping container,
Okay.
just like from a scoring.
You also got to think about space between crates or between containers too.
Well, and loading time, because the
Great.
blocks start out of the containers. So like there's a step of load the block into the container and then load the container into the plane.
Yeah, so that's
So
or if you had more containers, more crates per container, you'd eliminate some of that redundant time, if that makes sense.
yeah, it seems to me like the amount of time it takes per crate would be like a lot if you have to load very few per container and a lot of containers, and then reach a minimum when you, like, assuming you can do the kind of stuff I proposed, was it last week, that I think Laird gave a favorable ruling on, like the setting everything up on a sheet of paper to pick it up and essentially pour the crates in.
Yeah, he said we could do that.
Yeah, anyway, it seems to me like that would save a lot of time.
Now, would also, Laird, can you interject too? What the hell? Sorry. Can you guys hear people around me?
No.
Okay, cool.
Just a little bit of
A little
background.
bit, yeah.
Yeah, okay.
Might be me, I'm not sure.
It's quite loud for me. Have you said if we could like stack the Jenga block before we put it into the container?
I was just about to post something in the mock comp channel. I meant to send a clarification on that previously, but I think what I'm going to do is however many Jenga blocks you guys request, So let's say you request like 30 Jenga blocks,
Okay.
then that will be in 2 3x5 towers, Jenga style towers, like 3 interlacing 3, and they'll each be 5 layers high to start.
Cool. So Vlad, I think that solves our problem then.
Yeah, so like we could conceivably like have something. If we design the crates right, we could essentially make the crate such that you have the tower sitting there,
Right.
like put the crate down and close it on the tower.
Exactly. I was thinking the same thing. So 2
And-
crates.
So I would think that would get our ground mission down to a couple seconds, not counting the time to put the crate in the plane.
Yeah, you can also, there's different ways you could put the crate on the plane too. In or on the plane.
Okay, so you guys want to do 2 crates?
I'm thinking so if it's 2 towers. Wait, hold on. Now Laird, let's say we had like 100 Jenga blocks. Would it still be those 2 towers?
It would be 5 layers high. So it would end up being like, I guess, 6 2/3 towers.
Yeah, okay.
So you just get more towers, but each
Right.
tower is a standard size until you have to make a partial one because there aren't enough crate.
Yep, exactly. And what's up?
No, go for it. What were you saying?
I was just gonna say, yeah, if the number you, because it would be 15 per stack.
Right.
So if the number you request isn't divisible by 15, it'll just be as high of a stack as we can make with that extra number.
Okay, so there might be some glitches around edge conditions. Let's use so many crates that Laird can't find enough for us.
Well, I do have the advantage that we don't actually get to fly, so.
Hey, you're using my line against me.
Now remember, we can do it in the fall. They can build it in the fall.
It's true.
Uh-oh.
It's true. And honestly, that's a good idea. We should do that. So fair enough. But yeah, I mean, look, we can bulk order Jenga blocks.
Yeah. Anyway, in all seriousness, it does sound like it's worth making it some whole number of towers.
Yeah. So we have to have it divisible by 15. The crates, and then the containers is basically just the blocks divided by 15.
Wait, how do you get divisible by 15?
Oh wait, we
15
can,
crates per tower, right?
oh yeah, it's 3 layer, 5 tall. It's just how Jenga blocks work.
And
Okay,
then-
okay. So that means we can also make this equation easier. If we're doing whole towers, we can simplify it to crates equals just number of crates, containers is crates over 15.
Okay.
Yeah. It seems to me like ground mission could be worth a lot because it's a multiple.
On the bottom, yeah.
Yeah, so if we get it extremely small,
Then that could be
then we should be able to go on to the steep part of the 1/x.
which means we also have more lenience on the time and the takeoff distance too.
Yeah.
Because the empty weight and the battery weight, I mean, that's not really, the battery weight's going to be a pretty set value, right? And the empty weight is just going to depend on how we build and what we build.
Well,
Yeah, what would be a standard weight of a battery that you would typically use?
well, it would depend on how big a plane we're making,
That's true.
Okay.
which would
Well,
depend on how
big
many
is the
containers
plane?
we're trying to carry.
But also depends on how speed and the takeoff distance we want to.
But it is true that we'd have some incentives to push towards the limit on battery capacity and therefore towards a certain weight, because if we're making a little plane, we could use the battery capacity to make it go faster at a
True.
fairly limited cost and weight. And while I have not done the math to show this, I suspect that we'd gain more from the speed than we'd lose from the weight, as long as we didn't like make our plane start disintegrating and have to reinforce
also-
the control surfaces. But that's
the
Becca's
time-
problem.
The time and weight is kind of comparable because they're
Okay,
both.
fine. That's Jake's problem.
Again,
Y'all say that, but you're gonna be the new Becca and Jake, so it's your problem.
what's our problem? No.
Oh, just do we go fast enough to make our plane disintegrate?
No.
Just checking that you can physically perform to the
Yeah.
Believe, then we could probably do it. Like halfway to 55 pounds.
I have this suspicion that our theoretical high weight scenario won't work out to be the best score.
Again,
Felt like I was tripping there for a second because I sent the message and then saw it on the on Jack's.
Wait, what?
I sent a Slack and it popped up on your screen, and I had a out of body moment.
Jack, why don't you read your Slack notifications?
I don't do that.
And I figured it would be a great idea to make extra noise by knocking over my IMU 144 part. Actually, I didn't figure that would be a good idea. I just did it.
Also, quick comment as far as those warnings that keep popping up annoyingly.
Yeah.
Feel free to type warning space off in the command window, and it'll just turn them off.
Blair, is that best practices?
Damn straight.
Is
It's
If you
just a
don't,
really.
if you don't get a, go ahead, Blair.
I was just gonna say the reason it comes up is because you're going over that entire design space, which includes some absurd values, like a wing loading of like 0.1 or whatever is absurd, and so it's just like it can't do it, and so it's like, hey, that's gonna be your entire wing is your Spark hat. But like, we don't care about those anyway because we're not looking at the edges. So,
I'm sorry, did you say the wing is the spark cap?
yeah,
Flying through the air with like just an I-beam?
yep,
Good.
yeah. That's what all those warnings are. Is
So,
Spark cap width greater than a third of
what's
your core.
our coefficient of lift for an I-beam?
Not high. I mean, C channel has a high camber. I don't know.
I feel like you'd get some pretty bad separation though.
Yeah, just a bit.
And at high AOAs, like there would be some weird stuff going on with it acting as a scoop, but
I don't know if you get to call it an angle of attack if it's an I-beam, Blotto. I think you just call it beam move through air very fast.
well, I mean, what else do you call it?
wouldn't you have a little bit if it's tilted just slightly? You would have some.
Yeah, you
Fair
would
enough.
generate lift.
At very high speeds, maybe.
I mean,
I feel like though we'd be better off making a very short and fat I-beam, turning it such that its cross section is forwards and using that.
yeah, and then if you streamline it, that'd be even better. You know, it might even be.
Now, of course, at this point, we're just making an extremely low aspect ratio wing with big tip plates, but
I mean, we've done it. We've made that plane.
did it work?
Nah, I mean it. In the strictest sense, yes. Wasn't good though.
Okay, so where are we at right now? I think we lost Jack.
Yeah, which could be a problem since he was running the code.
Yeah. I
And
have an equation written down.
since I forgot to watch Monday's recording, so
What was Monday? We didn't do a whole ton Monday, did we?
Monday was showing you guys the code.
Right, yeah, okay.
yeah, so
Where did oh,
I'm gonna need to catch up on that.
So Thomas, how you doing?
I'm doing all right. How are you guys doing?
You good? Are you a freshman?
I'm a sophomore.
Cool. What's your major?
I'm Arrow.
Laird, aren't you mechanical?
Nope, I'm also Arrow.
Who's mechanical in the group?
Becca's mechanical. Yeah.
Okay.
Yeah,
Of the leadership, she is our only mechanical.
Andrew, what year and major are you?
I'm mechanical. I'm a freshman too.
Nice. Yeah. I'm freshman Arrow.
I think Jack Codlano is a mechie as well.
He's yeah. And then I talked to, you know, Carly, who's also an Arrow. Talked to her. I'm trying to get her into the club, and then there's one mechanical engineer that has like 4 years of flight experience. So
Oh, nice.
yeah, I'm trying to get him into the club too.
Hell yeah.
This Carly character get added to the Slack?
No, she's still deciding whether she wants to even attend.
Oh, okay.
And then Mason, I haven't.
Has anyone heard from Cody regarding the club? Didn't you ask him if he wanted to participate, Becca?
Yeah, I asked him if he wanted to do leadership, and he said no because he's busy with another club. And then I asked if he wanted to do mock comp, and he said yeah, but I don't know. I think he's just living his goddamn life. So he's been
As he
to a couple of the mock comp meetings, hasn't he?
I don't think he's been to any.
I thought he
Really?
was at like one of the like
He might have been to the very first one.
immediately pre-spring break ones or something.
Yeah. No,
Right.
he was going to pretty much all of them last quarter. Or at least a lot of them.
So was I.
Yeah. But he hasn't been to any of the mock comp ones, I think.
Yeah, in fairness, I've been MIA too. So
Well, it's not detail season yet. You're off the hook.
yeah, I was checking the schedule. I'm like, ooh, I'm gonna show up, but I better not show up and have to do something.
Yeah. No, you try.
Yeah, and you made the payload square this time, so what the fuck am I supposed to do?
You can still
For reference, I only work on axisymmetric objects. The new people.
Is that a job description?
I don't know if I have a job description.
All right. So where are you guys at with yeah, where are you guys at?
I mean, I can screen share. So what I'm trying to accomplish here is I'm saying, okay, so we have 2 crates. Well, okay, so I have this whole algorithm, and here are my variables I have to get in order to end up with a total score. Okay. And my plan is I know that the time this runs is going to be based on the total distance the plane travels, which we can probably basically just get from the PDF, because right, the field is some length.
Mhm.
So we can estimate how far the plane travels, but I'm also going to assume that it's traveling at top speed, and I'm going to take advantage of some takeoff distance and kind of try to run some sort of function from the sample script to
So
return these top speed and takeoff distance values.
does the sample script have a lap time function?
I don't think so.
Yeah, that lap calc parabolic wind, that function there.
Does it?
The main point of that is to output the lap time. I just plotted the top speed because it's easier to see because the lap time goes down as you get faster, and my brain was breaking, and so I changed it to V top. The contours don't look as nice for lap time, but it does output it.
It
It
does
does.
seem like
Okay, what variable is it?
It should be T lap.
All right, T and
what turn model is used in?
Okay.
So for turns, the lap calc parabolic wind assumes a sustained turn at the same power as your cruise. Yeah.
And how does it compensate for things like higher induced drag due to
So it can do that
22G turns or whatever?
Yeah, so in the drag polar, so what it does is it's basically the same code as the top speed calc, except instead of varying the velocity, what it does is it sets your plane at CL max, and then it varies the load factor until your like drag times your velocity equals the same power that you were pulling in cruise.
So.
Yeah. So it does it built in. What it doesn't do is it doesn't account for dynamical effects. So it doesn't account for like going into and out of a turn. It doesn't account for the fact that you have to decelerate into a turn and accelerate out of a turn. It's just if you were like gonna do a turn at some sustained turn rate, it would output that time.
Okay, so what value out of all these values do I want to return?
Well, so that is a matrix that has like basically your wing loading and your power loading as the axes, right?
Wing loading and
power to weight ratio.
And power to weight ratio, okay.
Right. So I think the each row is a different wing loading and each column is a different power to weight ratio. And so what I would do personally is I would output all of those values and then try to find the one that makes you score the best. That's how I would approach it.
Okay.
Because you also have takeoff distance for the same values, right? You also have takeoff distance for wing loading and power loading.
All right, so, I mean, how many variables can I have?
As many as you want.
Well, yeah, but how many variables can I have that aren't a set value when I'm trying to optimize? Because I guess I have in my mind kind of just like a, I don't know, like a XY graph of, oh, well, we need to have like one missing variable we're trying to optimize for at a time. But if,
I mean, if we're willing to make our computers and brains unhappy, we can have as many variables as we want.
That, I will say, it also, in addition to making you unhappy, is sometimes just doesn't work.
Yeah.
When I first tried to do scoring analysis this year, my first thought was, oh, well, I can reduce all of this to about 13 variables. What if I just iterate through all of them? And so I did. I iterated through all of them. I made a like 20 by 20 by 20 by 20 by 20 by 20 by 20 13 dimensional array. And my computer said, fuck you, Laird. Yeah. So somewhere between what you have now and what I tried to do is probably the sweet spot.
Can you do something more like that? I don't know if anyone's used the ease engineering equation solver, but it just like it only solves things simultaneously, and you can do like a table, like acting like it's Excel, and then it'll solve simultaneous equations. I don't know. I think it's kind of a disaster of a program, but maybe that's somebody's jam. Just put it out there. The Aero department would not have you know it, but there are programs that aren't in that way.
I guess I can't really think of how I would, I don't know, how I'd optimize for, or try to come up with the best total score when I have so many, like 3 or more unknown variables.
You try and turn them into some less variables. Don't know how to do that.
If we can do some sort of like numerically calculated gradient vector or something, that should work for any number of dimensions, right?
I don't know how that works.
I mean, if you're willing to calculate it, then yeah.
I don't know how to numerically calculate a gradient vector, but it seems like it should work.
So what you are stumbling on is the fact that there's an entire field of higher mathematics devoted to nonlinear optimization, and it is far beyond my pay grade. I tried at the beginning of the year. If one of you guys wants a research project over summer where you want to delve into like super complicated math things that I don't want to deal with, you should look into that. But so one of the things you do in that context is you use the gradient vector to try to essentially climb up the score function until you hit a top.
So basically just graphing in a z direction.
Basically, yeah, except with n dimensions instead of 3.
I've only done that with 2 dimensions.
Yeah, exactly. And that's why we try to keep it in that like 2-dimensional space of wing loading and power loading, is because it's much nicer to work with, if that makes sense. Yeah. I'm trying something real fast. I will let you guys know if this works. I have an idea for something.
Does is s underscore TL the takeoff distance?
Yeah. Yeah.
Okay.
We could probably combine cranes and containers, right? Into one.
Yeah, right. Because
Could we also could we reduce the ground mission time as like a basis for if we have X amount of crates and X amount of containers? And we have to like test this too. Let's say like 15 crates in one container takes us 1 minute, and then if we increase it by 15 crates, we have 15 more seconds that we add to that. We could try and do that. I don't know what a good basis would be though.
yeah, because like crates and containers are now unified into
Right.
one variable for scoring purposes, and should also be able to be unified for that, because we have a method for packing the crates into the containers that's discrete to the unit of 15.
Right. So
And then
I'm wondering
yeah.
if we take some like good knowledge.
So
Let's say it takes us. How long do you think it would take us to just slip the crate right onto the containers, or the container right onto the crates?
one question regarding that I'm going to need to ask Laird is, what condition is the plane in at the start of ground mission? Like, do we have everything essentially like prepped to load, or does it have to start out in flight condition?
Everything has to, so all of the payload has to start out unloaded, which includes your containers. The
and
containers
we have the plane like opened if it has doors that close or something like that. We can have those open even if they have to be closed for flight.
Yeah.
It's basically
Okay.
set for everything to be loaded straight into it right after we get it into the containers.
Yeah,
So
and we should be assuming that we have lots of like latches on stuff such that when you close it, it stays closed.
right, and quick latch and not like tie like 5 knots to keep it in place.
Yeah, because like we can take our time with opening it.
Right.
There's-
What would Laird, for like previous, or anyone that's had previous experience, what would be like a ground time that you guys have had?
Act it out, get some blocks. Even if you're just moving your hands, you know, like how long it might take you to do the sleeve. Just be like pretending you have a sleeve and then like scooping it up and putting it over there. Like legit, it's like human operated. So it's how fast you can go.
Right, okay.
Yeah. If anyone has Jenga blocks, definitely fuck around with that.
So we're
But
gonna,
also cute thing about the ground mission, you start outside of the box. So you get the fast runner to do it, right?
Well, how far away do we start?
Oh, it's very short, but people still run.
400 meters.
Yeah, put
have to
it like
make
a
sure.
sprint at the
Yeah.
front of
But
it.
we also have to make sure that we're not going so fast when running up as to knock over our towers.
Yeah, that wouldn't be
That's
good.
true.
or trip and like land on the plane. Oof.
I'm more scared about the towers.
You also have to count that the wind is knocked over too. It's another
Yeah.
variable gotta optimize in mountain. Okay. Okay. So
I mean,
right
my
now,
guess would be like 5 seconds per container plus some constant.
so right now the only I guess independent variable here is going to be the s_TO. So the time or the distance to take off. So how do I plot this matrix or optimize this against score and score total? I need some help. I'm brain dead here.
So there's a lap time function. Is there also a takeoff distance function that'll do that like as a function of wing loading and power loading? So like we don't have to deal with figuring out that function, or
Yeah, so
we have to.
this was based on wing loading and power loading. I guess my idea here is, since that's two variables, we could kind of have we could kind of plot this matrix over some domain, and then have score
it
score
is.
will be like some z-axis value.
It is
Like
looking
matrix
like
pi.
we're down now to essentially number of containers, wing loading, and power loading, but those are somewhat connected.
Yeah.
Yeah, the biggest guesses are the number of crates
Yeah.
we're doing and the weight. The weight's a big
Yeah,
one to just randomly guess.
because
Oh, did you just guess 20 pounds for our weight?
Yeah, I mean, I think I was
Batteries
thinking like
21 is more of a reasonable estimate.
what?
I think 21
then-
would be better.
21 would be better.
Yeah.
I don't know,
Whatever you
I'd be
want.
guessing less than that probably if we're only taking 2 crates, because how much does a Jenga block weigh? I'm gonna see if I can look that up.
0.377 ounces. It's in the rules.
Oh, it is.
3.7?
Yeah. What's up,
That's
Andrew?
impressive to have memorized.
Wait, you said
I literally just looked at it.
0.0377.
So we're looking at just over 0.7 pounds of Jenga blocks for 2 containers.
How many pounds?
0.7.
Well, that's not too bad. Because that's saying that
So
Jenga blocks aren't even, are like 4% of the total plane's weight.
yeah, so basically what I'm saying is I think that if that's how many crates we're having, the plane could be made to come in far lighter.
So, yeah, one thing that I would also suggest doing is if you have like a rough idea for what a small plane version would look like and what a large plane version would look like, you can run through the calcs on just those versions. Instead of trying to do like an iterative optimization, you can just like, if we were to carry a single Jenga block, what would that plane look like? And then if we were to carry like 200 Jenga blocks, what would that plane look like? Right? I mean, honestly, 200 Jenga blocks is a lot of Jenga blocks. But like weight-wise, you've already figured out that Jenga blocks are not that heavy, right?
Yeah, I mean,
So-
200 sounds like an actually pretty reasonable thing. For a small plane, I'd suggest that we do, I guess, for at least one small plane estimate, not necessarily the only small plane estimate, we try like 1 tower. Because looking at that weight estimate for a tower of Jenga blocks, I would count that as small.
1 tower.
Yeah.
I think, I mean, if we, so I guess last meeting, Matisse and Andrew and I were looking at the Cessna 208, I guess Grand Caravan, whatever. And that we were kind of basing a few of our assumptions based on that. So what we can do is we can look at, hey, so the Cessna has a useful load, I think it means payload, of 3,500 pounds about. And then as a percentage of its total weight, that's like 40%.
I think we can do better than that, though. Right.
Possibly because we
only
are
have
dealing
to
with
fly
a
for 5
smaller
minutes.
plane. So
I don't think we're gonna have above 300 or 3,000 pounds though of payload.
3,000 pounds would be a very large estimate.
Yeah.
well, yeah. So if this plane was able to have 40% of its total weight be its payload, then I think that's
Yes.
kind of a reasonable assumption for us.
It
to work
probably
on.
depends on what exactly we're optimizing for. Because if we're doing like small and slow, we might be able to do that. If we're like all out optimizing for speed, I would expect that we wouldn't.
Yeah.
Also, did you guys get the one stack is just is about 5.5 ounces.
Yeah.
Okay.
Okay.
So 1 second.
Sorry, how many is that?
Yeah, how many pounds is that?
That's 0.35 pounds. That's about our, it's not all, it's about our 40%. So if our plane is 1 pound, we would have 1 stack of Jenga blocks. According to the Cessnas.
Yeah. So leadership, do you guys have any like historic DBF weight fractions?
That's quite a question. Laird might know when he gets back, but I think since we usually build with like balsa and foam, our structural weight is usually pretty low, lower than other teams usually. However, if you're asking for a number, I have not worked with such a structural number, but I would think more in the range. Well, I mean, with your discussion about like wanting to overpower it, yeah,
Well,
so an efficient aircraft has like most of the weight dedicated to like payload, right? But I don't know how you fit propulsion into that idea.
Yeah, I mean, I think that among that, that's also something that would change as far as design space when we're accounting for stuff like what's possible to build.
We do
like-
have like a weight estimate scripts. Laird, if you know, they're asking about historic weight fractions or payload weight fraction. Whatever
Oh
you
yeah,
call it.
I can send that spreadsheet in the mock comp channel. But Becca, you were about to tell them about the weight estimation code. That is given to them. That is in the sample script and stuff as well.
Uh-huh. So that's one way to
Yeah.
help you with your weights. It's pretty good for like balsa build.
Oh, we lost Peter.
So here,
Hi, Peter. Hey,
I
Dan.
said- I'm good. So you guys, I'm sorry I missed Monday. What's it called? Was I here Monday? Oh, I was in it. So the plane you guys said about the 40%, is that like a fast plane? Like what kind of plane is it? I didn't really catch that.
Cessna 208B. It's like a small fish plane. Has wings on it.
That's crazy. A plane with wings.
It's
Like, what is it?
unfortunately above our maximum weight.
Yeah, or else you would have copied it. Like what does it do? Like, is it made for like carrying stuff or like just going
Yeah, so it
fast or
can
looking
be-
cool?
It can be transitioned between, I believe, passenger and payload.
Okay.
It's a small, like, I think it's a 12-seater max.
Yeah,
when-
208Bs are 12 seaters, and they have a removable payload container below the chassis where the
Yeah.
passengers sit.
It-
Okay.
By my estimates, it seems like it could carry well over 8,000 Jenga blocks.
It's good. Oh, so you guys thought that was like
Or
that's like closest
sorry,
representation of
correction.
what
It
our
could,
plan's trying to be.
Yeah, it's a good scaled up kind of version of
Yeah.
our plane that we're gonna try and.
Yeah, I am totally cool with the 40% then.
correction, it could carry well over 8,000 containers. So
Gelato.
we're around 127,000 Jenga blocks.
Damn. So Laird, you better bulk order your Jenga blocks then.
Sounds good.
The takeoff distance might not be 15 feet, but it's okay.
That are aimed is that part of the rules? It's 15 feet?
I think that's what we're aiming for.
Okay.
Okay. The rules maximum is 50, but
50, okay.
if you guys have like an aim of 15, that's different. But
Sure, we'll aim for 15 now.
Is 15 realistic? Like,
Sure. 15 feet.
I from experience, I have found, I think that would be realistic. Like, I think 2 years ago, I think we were taking off in like less than 5 sometimes.
okay.
I mean, to be
Less
fair,
than 5
we
what?
were hella overpowered, but
So I'm thinking like 4 motors, 1 battery.
it wasn't quite, but it was like it was a 6S, and
That's
a
a
pretty
big
beefy
battery.
motor. Yeah. So it was like, yeah, it was pretty
I think it'd
beefy.
be cool for you to plane that had 4 motors in each wing. It was just like,
You could do it. I mean, I've been meaning for a while to do a trade study on having multiple motors. I think it is just always less efficient unless you have some structural reason. But
we might have some structural
you might,
reason, because
yeah.
mass fraction benefits us since we're penalized for non-payload weight.
Now I'm wondering if we could use batteries instead of like maybe not for like the very center of the spar, but like for the kind of the ends of the spar. We have kind of like a reinforced battery to save weight. We could have 2 on each side, which would increase our.
I feel like doing much with the batteries would be kind of hard, but mounting them in the wings could be good, such that they reduce the bending moment versus mounting them in the fuselage. And actually, speaking of that, could someone tell me why it would be a bad idea to do like a twin fuse with the fuselages like well out on the wings to try to reduce bending moment? Like, it probably would be, but could you tell me why?
Wouldn't it make turning harder because you have greater moment of inertia?
Yeah.
Peter, are you aerospace maybe?
I am, but I feel so out of place because everybody in aerospace like, yeah, that's my favorite plane. I've been flying planes since I was 2. You know, I've been flying since I was 3, and then I'm like, I just pick aerospace because it sounded cool. So I don't have any elements in aerospace.
Peter, I feel you.
Don't
I feel you.
I'm more of a
don't feel
climate
bad, Peter. There's a lot of us.
I feel like
Good.
all of us did it for some variant of it seemed cool.
Yeah. No, I certainly people. Yeah. No, I one of my friends back home went to a different school, but also for aero. And when we hang out, if he like sees a plane overhead, he'll be like, "Oh yeah, that's this plane," and I'm like, "Bro,
My friend can do that.
that shit's in the air. That's all I know."
No, but he can do
I
it.
tried to do
I have
that.
a friend like that
It's
too.
coming from 2.
Yeah.
This
No.
is crazy.
I
Yeah.
have a hard time with a lot of them, but I try.
Yeah.
I don't know how you.
No.
I don't know how people do that.
If they'd be willing to show me, that would be great.
Yeah, no, he's like it's at 747-8. It's going from here to here.
Yeah.
I don't think he's gotten to a stage where it's like, yeah, it's like 7 hours and 44 minutes. He hasn't got to that point, but holy shit. I'm like, yeah, it's a plane. Cool.
Gets out a telescope and reads registration.
He's probably just got that like,
The app.
is it ABS radio or some nonsense? You can spy on all the planes. He just got it on his Apple Watch or some nonsense.
No, we'll be like, we were sitting at a baseball game, right? And there's planes that come overhead because there's an airport nearby, and we're like just watching, right? Nothing beforehand. I'm like, Zoli, what's that plane? He's like, yeah, it's a blah blah blah, like blah blah. I'm like, cool, it has 2 engines. I know that. But
My dad's a pilot, but a plane is a plane is a plane is a plane, right?
I don't know. There's some variation.
There's big plane, small plane.
Helicopter. Or do those count as planes too?
Small plane with spinning on the top.
Yeah, prop plane, not prop plane. Vertical prop plane.
Exactly.
All right. Sorry, I took us off track. What were we talking about? Were we talking about to a double fuselage? I think that was the last thing I remember.
Yeah. I think you were saying something about a something moment.
Oh yeah, I said the reason we wouldn't want to do that is because it would increase our moment of inertia. I mean, or what is it called, the spinning thing, and it would make it harder for us to turn.
I would think that would be moment of inertia.
I think so. I thought there was a specific one for rotation, but I don't remember.
We learned that in Becca.
Well,
The moment of inertia.
you asking about, you trying to say polar?
No. Do we learn about what Peter's talking about in mechanical engineering?
You'll learn it in
That's-
statics and dynamics.
Dynamics, yeah.
Yeah.
We'll probably talk about even more detail in like intermediate dynamics and stuff.
Yeah, we got intermediate dynamics.
Well,
There's-
I'm in
there's some-
Dynamics 3, Becca, so
Remember that?
There's a
cute
third
little
one?
kinda, yeah.
Oh, ew.
Larry, remember that cute little problem I showed you with like an induced moment from like a plane taking a turn with like a hecka inertia rotor, and it was like gyroscopic
Inertia rotor.
bullshit. That was
Yeah,
a good time.
Yeah.
We get 2 planes questions in all of dynamics, just 2.
God. Right now we're like doing some review from our last dynamics class. And so we're still doing like torque free motion right now. And I'm like, we did this like 4 times.
Cute.
Rotary wings aren't allowed, right? Even if they're unpowered.
Yes. Wait, why would, okay, yes, they
On
are
a
not
gyro.
allowed.
Isn't rotary rings just a helicopter?
Well, or
Yeah.
not a gyro or
Oh.
something. Oh, and would powered lift count as rotary wing? Like if we made a tilt rotor, would that count as rotary wing?
I don't know.
It seems like it. And like
My only concern is you can't have infinite score. This is my concern. Because takeoff distance is in the denominator. And so if you literally VTOL, then that's literally infinity. And that's no fun. So I'm gonna say no tilt rotor.
Wait, but
Well,
that's
it would.
hold on. Sorry, Becca.
No, it's
The
okay.
takeoff distance is added to the time. So it's not necessarily infinite.
yeah,
It is it shit. I'm forgetting my own rules.
Well-
Is it added or multiplied to the time?
it looks like it's multiplied in that code at least.
Well, so it's going to be divided. So you're going to end up, if you have 0
Yeah.
takeoff distance, then it's whatever over 0.
Wait, hold on.
Infinity.
I gotta check this then.
Yeah. In the rules, it's multiplied.
Oh, not bad. So
yeah,
yeah,
I mean that's the whole point though. Like if we get 0, then we get infinite score. We break the system. We don't need to optimize anything else.
I'm gonna say that at no point can a spinning rotor be your primary source of lift.
I mean, thing is though, looking at some of the practice videos from year before last, some of those takeoffs were steep enough that I think the prop was your primary source of lift.
At the discretion of the flight judge. I am the flight judge. Don't be mean to me.
Laird, I'll give you a bagel if you ignore our tail rotor.
Oh shit.
Was anyone steeper than us last year?
Well, I don't know.
I feel like we were pretty heckin' steep.
We were very steep. To be fair, we didn't get to see everyone's like max takeoff, because that like we wouldn't have taken off like that for the comp. That was takeoff testing. So we didn't see that video for other people, I think. But
Okay, so I came up with one other way to cheat.
Yeah.
Which is that
Okay, got it.
takeoff distance is counted based on displacement, not distance. So if we put a variable pitch prop on it, back up a ways, then take off, we can get a 0 takeoff distance.
I'm also gonna say that's not allowed. No, oh fuck.
Okay. I'm running into an issue where it doesn't really like my function that I'm calling. And the function I'm calling is a sample script. And it says the issue is line 11.
So first of all, there's a red underline under sample script. That's never good. What does it say? It might be unused. Okay, so what is that saying? Like why is that like that?
Well, there's also
That's
the
a good question.
unable to define because it has the same name as the file.
Well, that is usually what you want in a function file,
Huh,
but that's a problem, right?
weird.
Because what kind of file is this?
This is just a MATLAB file.
It is, but it's got commands before the function call,
Oh,
right? So A, if you're calling a function, you probably don't want to clear all your variables.
yeah, that's intelligent.
So I would comment that out or delete it or something. And then I
What
would put
does it
the
do?
add path inside the function. That, so if you go to your like folder where you have all of the things, oh, I mean it's on the left there. That just makes sure that this is in the path, so that it can call all of the functions inside of it.
Oh, cool.
Yeah. So that should work better now.
Okay.
Let's go. Different error. Oh.
I mean,
You can annotate your screen.
By the
you
way,
guys-
you're only sharing your MATLAB window, so we can't see like plots and stuff when they come out. Just FYI.
Oh,
Can you guys see this at all?
Yes.
Yeah.
Oh, sorry.
yeah.
I thought I
here-
could see that.
Yeah. No, it's always fun when professors don't know that that's on. I remember at one point last year, everyone just like gradually colored out Dr. DeTurris's icons on the bottom of her screen.
Oh, Dr. Torres?
Yeah.
Wait, we got a real thing.
Yeah,
It was more than just
yesterday I was in
icons.
class. I know, 2 days ago I had class with her, and she somehow started playing some video of like it sounded like a toddler beat.
Are you talking about the baby that was
I
singing?
saw that. Oh my
That
god.
was so fucking funny.
I literally, oh god, yeah. I saw some people post that on their stories. I was like,
It's so funny.
She even ended the Zoom session and then like restarted it when we all got back in. She like unmuted herself and it just started doing it again.
What happened?
She had this like home video of a baby or something like singing the Itsy Bitsy Spider and some like random song. And every time she went to like say something, it would get really loud. And so she had to like stop lecture because she couldn't.
Wish I was in that class.
I don't know about that one.
What class is it?
It's
Thermo.
yeah, it's our thermo class.
I'll stay where I am right now.
Who remembers the Mach number calculation?
Yeah, what do you need?
I need the Mach number calculation.
For like, given what variables, I guess. There are many.
I have U infinity, P infinity, and T infinity. Oh, I guess A is equal to square root RT.
Yeah, gamma RT, yeah.
Right, yeah.
I don't know, I feel like it would be easiest to start with the Mach number.
Yes. Where did So are we trying to get like the I forget the variables. Was it power to weight and then lift to wing area? The graph,
Wing area, or like weight to wing area.
weight to wing area. Do we get one or do we not? Or do we just error out?
What do you mean?
Did we get a graph or did a jack screen or do we not want get one?
So the sample script, the function he made out of the sample script ran, but it looks like he had an error on line 16 because it looks like those variables, I don't know what the error is. Oh, dots. You need dots. But
What do you mean we need dots?
Peter, is there
Yeah.
someone sleeping behind you?
Yeah, that's my brother.
Okay.
Please ignore him.
yo, Jack, you need dots.
I mean,
Oh,
what?
also two things.
Oh, whoa, I know what you mean.
Yeah, first of all, the output of sample script is takeoff distance is like STO, not TOFL, just the way I define the variables differently. And so it's not recognizing that. But then also you're gonna need dots.
Yeah. Yeah, so I outputted the two matrices. Right, yeah. And then I was gonna figure out what I was gonna do with those matrices in this code, which I still haven't figured out.
So Jack, I think you got to change the TOFL.
Yeah, that.
Should be S.
But do we want? I guess we want to optimize for. Well, okay, so we have two matrices to deal with: the time min matrix and then the what is this one? Takeoff distance matrix. And I want to plot probably one of them, or I want to use one matrix so I can get a matrix of score total. So I'm trying to figure out how I'm going to make one of these matrices just a single value. So that's my thought process. But
well, so what are why do you want to make only one of them a single value?
Because then wouldn't we have four values that were four unknown values?
Well, so the way I would think about it is that the unknown values are just the wing loading and the power loading, right? So you know the time min and the takeoff distance at any given combination of wing loading and power loading, right? And so since those are both in the denominator of the score function, you could just make a score matrix, right? And you could just element-wise multiply those together and then divide everything, right? You see what I'm saying?
Yeah.
So you could just make like one matrix with all of that already accounted for.
So, okay. That makes sense.
Yeah.
Right, yeah. And that would make score 2 a matrix probably. Do I have to do a dot slash? Okay.
Yep.
when I'm just multiplying a constant by a matrix, I don't do the element-wise multiplication, do I?
No, you don't need to. It doesn't hurt, but you don't need to.
Okay, well, we'll see what happens.
Mm.
These seem like very small scores.
Wait, so what are we looking at right here?
So I will say, I think your time is still in seconds.
Oh, okay. So it's the times in seconds when
Yeah,
you end up with t underscore left.
yeah.
Andrew, I think we were looking at like a matrix of possible scores
Got it. Okay.
with the current configurations we put in, and it was like not even close to ones. 'Cause,
What's a normal score?
well, I think that's for us to determine also.
Or like from previous years?
So in previous, depending on the competition, the scale of the scores is literally anything. I think 2 years ago, like it made a lot of sense to get scores in the hundreds, and then this year, all of the scores were between 0 and 1. Like it just depends on the equation that they give you.
Weird. Okay.
Yeah. So in this case, it's kind of up to you guys to determine what a feasible range of scores is.
That's delightful.
Laird, correct me if I'm wrong, but the scores would also depend, like the range of scores would theoretically also depend on like the wind conditions of the day too, because that would affect like your takeoff distance and all of that, right?
Yeah, absolutely. So the lap calculations account for wind, and you can set it based on like worst case scenario.
Okay.
But the takeoff ones don't. And that's something that I don't know how to, I don't have the data to fix that right now. I'm going to try to get data on that next year, but for now, like we don't have that. So
Those
Gotcha.
numbers look kind of good. Better than
Yeah,
before.
theoretically we could get a score of 11.4.
it certainly is a number.
Report too.
What did you say, Andrew?
Multiplied by our report, because we still have that as something that we haven't talked about.
Oh,
I just said our report would be a score of 1. How much is it actually?
Out of 100.
Out of 100.
Yeah, but I mean, it doesn't actually like matter because whatever you assume for that isn't going to change depending on your design parameters, and so
Right.
just depends what scale of numbers you want to look at. So I guess
I think we
you
should
get
I feel like I'll
1100.
like the numbers more if it's 100.
Fair enough.
really? I feel like it'd be too big.
Yeah.
Yeah.
Oh, 1100. That's beefy.
I think we should put it back down to 1, even though big numbers make us feel better.
Back down to 10.
Okay.
Big isn't always better, guys.
I don't know, Andrew.
Okay,
All
cool.
That's nice. So that score, what is that? What are our inputs to get that score?
So that would be assuming that that's power loading. That's really high power loading with a really low wing loading, I think. Or is it really high wing loading?
No, you got it. Yeah, it's high power loading, low wing loading.
Okay.
And wing loading is the amount of force on the wings.
Yes. In this case, it's really the wing loading in steady level flight. So it's just the weight of the aircraft, or the weight of the aircraft divided by the wing area.
Cool.
Also, so one thing to think about is if it looks like the score is driving you in one direction, what kinds of especially because that's kind of an extreme direction, what kinds of constraints do you think you would have that would stop you from just having an infinitely high power loading and an infinitely low wing loading?
Obviously, the battery would be a hard limit for the power loading. The wing loading. Do you have a maximum dimension?
Nope.
Oh,
Yeah, although
10 feet.
structural weight would catch up with us at some point.
I see.
And
You said there's no size, but don't you still have the fit in a 10 by 10 box?
Oh, certainly. It has to fit in a 10 by 10 foot box. But
Yes, that's definitely a size.
are we allowed
constraint.
variable
Nothing-
geometry though?
I think
No.
you'd hit the 55-pound weight limit before you hit the 10-foot box limit. But
Don't
Yeah.
Because
underestimate
if
that.
you're allowed variable geometry, you could just make a telescoping wing and get like 20 feet.
All these chains.
theoretically,
Andrew, were you saying something?
Probably. It's okay.
Sorry.
I have no idea what.
Great idea lost.
No, I think I was saying 10 feet was our max. We
Okay.
talked about that on Monday. How like 10 feet would be like the biggest we could do for like 55 pounds.
Okay. I'm mentally exhausted from writing all this MATLAB.
Yeah.
Next time, someone else is gonna have to. Someone else will be responsible for MATLAB.
I can do the MATLAB next time.
All right. As long as it's not me. No, just kidding. So what are we trying to sorry, I wasn't here for the whole meeting today. So what do we get done today, or what are we in the process of getting done?
Well, so we calculated the score equation.
Right.
That took us about 20 minutes, and then
Okay.
then I think as you were coming in, we were just kind of like maximizing it for the best score.
Okay.
I think that's all we did today.
Yeah, I can go through the assumptions that we made when writing this code. So I guess the first assumption we made is we picked a random weight. Hey, it's gonna weigh this much total. So that's a big assumption. And then based on the what do you call it? The Cessna Grand Caravan,
Yeah.
we said it's kind of a passenger-ish plane, like it's kind of a medium-sized one. We found the ratio of, okay, so it can carry about 3,500 pounds, and then at that weight it'll be 14,000 or some 8,500 pounds, and so that means it can have a payload that's 40% of its total weight, and so we calculated the number of crates and containers based on that 40% ratio.
Mm-hmm.
There are two variables, that is battery weight and then the rest of the plane as empty, or is that total weight? Or that's empty weight. Actually, that's not even containers. That's another variable actually that we have to go back and fix. But yeah, so we have to figure out the battery weight, how much the plane should, I could actually easily calculate this. So we have to kind of get some battery knowledge.
Does that say that your batteries weigh 20 pounds?
Yeah, that's what I said. Correct.
I'm okay, just wondering about that, but
How much do 200 watt hours or whatever it is we're allowed to have of lipos weigh?
Oh yeah, you can just look that up.
about 4 pounds total. Right, Becca? That's what I was giving you. About 2 pounds each.
I don't remember.
Fair enough. Yeah. So what I would do is I would look up the specific energy or like the specific energy of LiPo batteries, and that'll tell you like watt hours per kilogram or whatever, or per pound. Is probably more useful.
Also, to get our 21 pound to like a more kind of useful weight, if we have 21 pounds with 40% payload, that's 356 Jenga blocks, which is 23 containers.
That might be a little much, yeah.
Which is, yeah.
Maybe.
Oh yeah, we
Peter-
also assumed 15 containers per crate. Then we also assumed all of the light variables like lift and drag, wind speed, aspect ratio. But these are all very standard numbers, so
Okay.
these aren't as iffy as the weight and the battery thing, and then how much power we can actually get out of the battery.
All right.
Yeah.
If you're thinking about weights, last year we were about 16 pounds, but the year before we were like 6 pounds. Yeah.
I think
wasn't
we
last
were-
year's pretty insanely big.
Yeah, last year's was pretty heavy and we were like 15 pounds. The year before, I think we were 9, not 6, but yeah.
Okay. Well, maybe on one of the missions we were 6. Maybe I'm thinking of something, but if you look at historical planes, especially our club, and especially when your score is divided by your rated aircraft cost, which is it always or sometimes weight? I don't know.
Usually has some weight component. Oftentimes also has other components about the size, but usually just
Okay.
trying to make your aircraft small.
Also,
Yeah.
if we have 3 containers, that's going to give us about 1.1 pounds of payload, and our total, if we're doing a 40% payload, would be just like over 2.5 pounds of plane. So we could definitely do a bigger plane if we wanted. Bigger comparison to the crates container.
Is assuming your payload fraction, is that like an intelligent way to go about this?
I've done it.
So
Are you
out of
questioning my
nowhere-
intelligence?
I didn't ask if you'd done it late. I asked if it was intelligent.
I mean, look, especially at this stage, I'm gonna say that looking at aircraft that exist, either real ones like that Cessna or historical ones, like I sent a spreadsheet into Slack with all the historical aircraft. It's not a super well organized spreadsheet. One of my projects this quarter is going to be to work on that, but like, and just kind of basing it on that and modifying as needed isn't a bad move. And so I would say that assuming something like a payload fraction isn't terrible. No.
Well, I think because our payloads are so lightweight, size is going to be an issue before you even have to worry about like how much they weigh, you know?
I would agree with that, yeah.
That's
You're
fair.
going to get a thicky plane pretty quickie.
Oh, I also just remembered we did set the wingspan to be 10 feet.
True.
That's certainly a decision.
These fishes really be out here.
I mean, if we're making the plane 20 pounds.
Also, I
Like-
will say, I don't think you're actually using the takeoff weight or the span or anything in any of the numbers that you're pulling out of this function.
Yeah, because until we calculate the final score, we're not using the number of containers or that, right?
Doesn't the span go into the lap time calculation?
Nope.
Well, because the
The aspect ratio
lap time
does,
is
but
Not even the takeoff, how long it takes for
well,
the
because
plane
that
to-
should be
no. So
power to weight ratio, right?
yeah, if you look in the sample script, if you look at the functions that are used for those, if you look at that for loop in there, If you scroll kind of, or first, if we look at the, here, 1 second, let me annotate. So the inputs for the takeoff function are just these. So it's just power to weight, wing loading, and then the CL and stuff, and the altitude and the propulsive efficiency. And then if you look at the lap calc, it's the same deal. It's just wing loading and power loading. And it's just doing that for these entire vectors.
Okay. So what is so what does the span go into then?
This stuff. So all of, if you scroll up a little bit, I've commented here that these are arbitrary values for the weight estimation function. So I only put those in just to show you that like what the weight estimation function does. So that'll, if you do want to assume stuff like a payload weight fraction and stuff, I would mess around a lot with that weight estimation function to try to find out like if we have a 40% payload fraction and this wing loading, this power loading, and let's just get like, maybe we iterate through takeoff weights or something like that. What kind of empty weight are we going to get? What kind of battery weight are we going to have room for? Is that going to give us enough battery to last 3 laps or whatever? Like that. That's what I would do with that weight estimation function.
Why does the weight estimation function have a takeoff weight?
Because so if you go to that function, so if you scroll down a little bit, and then can you, not that far, sorry, to the for loop. Yeah.
Okay.
If you click, if you right click this and hit open. So what you can see is the outputs are empty weight. Ignore those two. Those are easy to calculate if you give it a, anyway. But aspect ratio and wing area. And then the inputs are your actual total takeoff weight, and then your wing loading and power loading. So it's basically trying to say, if you want to have this much power with this much span, how much of your aircraft weight is going to need to be structural? That's what this code tells you.
Okay.
Oh.
Okay.
So does it? So Larry, is it possible to give a? If we put in the wrong numbers, will it give us an empty weight that's greater than our takeoff weight?
There should be a check on that. So if you scroll down, I think all the way to the bottom.
It just calls us stupid or something.
Yeah.
Okay. Yeah.
There used to be a warning.
Plain stupid.
But yeah, I mean that's basically what that warning command does. But I've just had, I think I just changed it so that it just outputs not a number, if that's the case.
Okay.
But yeah.
Cool.
One other thing I do want to mention before we go today is that Saturday is the plan is going to be to move a little bit into preliminary design. At least for the first 2 days of preliminary design, it's very similar work, so we can kind of just keep continuing this. But we should very soon try to get some numbers, whether they're like well supported or not, I guess is how I'll put that. That way we can actually like talk about some of the other things like sizing an airfoil and sizing a tail and stuff and propulsion system. So I would say that the goal for Saturday should be to get like potentially in the first hour of Saturday, get like the plane you're building, like how many Jenga blocks, what wing
Okay,
area.
so that, I think that's doable because we're already getting some numbers.
Yeah.
It's just like a little bit more optimization.
Some
Alright.
numbers better than no numbers. Okay.
Yeah.
But yeah, that's just as far as timeline coming up. So
No, I like my scheme to get 0 takeoff distance.
I mean, look, if you can do it without having your propellers be your primary lifting bodies, then you win.
Okay, so here's what we do. We have a bunch of engines like potted below the wing, and then giant ass flaps. That way it redirects the prop wash vertically downwards.
It's similar to like the thrust vectoring at the back of I forget which plane it is.
Yeah, there was some plane that did this, I think. I'm forgetting what it was though.
Well, there's the Harrier that has the redirection of some stuff, and there's one of the F somethings can actually physically vector it.
Oh, the F-35C, I think.
Yeah, but there
The
was
vertical-
some experimental at some point that literally had like props and then like weird giant flaps to direct it downwards.
There's the Osprey that can tilt rotor, but I don't think that's allowed, is it?
Again,
Yeah,
that would
that's-
have your propeller be your primary
That's not
lifting
allowed according to
surface.
the decree by Laird.
Yeah,
Damn you, Laird.
I'm sorry.
No, it's okay. We're not mad. Don't worry.
Appreciated. Yeah. All right. Jack, you should send your code in the Slack channel as well. Just
Yeah.
so people can take a crack at it before
Yeah.
Saturday as well.
Right. Is that it for tonight?
What's tonight?
Sorry,
Here,
what?
nice, just getting started.
Oh, my bad. My bad.
I haven't even started homework.
Hard night for business students.
I tried starting homework and I'm stuck on the first problem. I shouldn't be.
That's
Just
a mood.
unfortunate. Yeah.
That's a mood.
What's the problem?
It says using MATLAB, plot the streamlines of the flow